Today we will study about laser. Now what is laser? Laser stands for light amplification by stimulated emission of radiation. Laser definition: it is a device that produces highly intense, coherent, monochromatic and unidirectional beam of light. These are the properties of laser. Like key features of laser: monochromatic means light of a single wavelength. Like red light have wavelength 632.8 nanometer. It is a laser is a coherent, like all photons are in same phase, like soldiers marching in a step. Directional, laser is a very narrow beam, almost no spreading. Highly intensity means it is a concentration of energy is in very small region. This makes laser light very different from ordinary light. Like bulb and tube lights are ordinary light. They spread in all the directions and they have range of many wavelengths. Now, difference between laser light and ordinary light. What is the difference between laser light and ordinary light? Laser light are highly coherent. Ordinary light are incoherent in nature. Their coherence length is of order of few kilometer. It is highly directional. Their coherence length is of order of a few nanometer. Ordinary light is divergent. Coherent light means, what is the meaning of coherent is that all the photons are in same phase. The next difference is it travels in only one direction. Laser light travels in only one direction, which is parallel to optic axis. And intensity of ordinary light decreases with distance. As distance increases, intensity of ordinary light decreases. It travels in the form of small pulses of small length and short duration. Now, laser light is highly monochromatic in nature. It travels in the form of large length and long direction. Monochromatic means it is a light of single color. It is a light of single wavelength. Wavelength does not vary. While ordinary light has a range of 100 to 1000 Armstrong. Ordinary light have a range of 100 to 1000 Armstrong. It is polychromatic as it travels in the form of short pulses of small length and short duration. Now, spread of plane wave front is less, hence they spread less. Laser light, spreading of laser light is less. It is less divergent, while ordinary light spread heavily and their divergence is more. Laser light is used in where laser light is used? Laser light is used in eye surgery, tattoo removal, CD players, laser printing, barcode readers, fiber optic communication. Ordinary light are used in lighting the small area where divergence of light sources is very important. Now, laser light can be focused to a very sharp spot as laser light is highly directional. While ordinary light cannot be focused to a sharp spot as ordinary light is divergent. These are the difference between ordinary light and laser light. Now, what is the history of lasers? When it were formed? So, first of all, in 1917, Albert Einstein proposed the concept of stimulated emission of radiation. It is a theoretical foundation of laser. That at that time there was no application. Theoretical foundation was given by Albert Einstein in 1917. In 1953, Charles Townsend, USA, he invented the laser. Before laser light was invented. Full form of laser is microwave amplification by stimulated emission of radiation, and he got Nobel Prize in Physics in 1964. Then in 1960, H. Meeman built the first working laser, that was ruby laser, in which he produced the light of red light. That was laser light. The color of laser light was red. It was of 694 nanometer and father of laser. This was the main starting of laser. It was called scientist Theodore H. was called the father of laser. Then in 1961, Ali Jawan William Bennett, he developed the helium neon laser. After ruby laser, helium neon laser was invented. This was invented by William Bennett. The wavelength of that light was 632.8 nanometer. It was the first continuous laser beam. Like a UV laser was light comes in the form of pulses, but in helium neon laser, this is a continuous wave laser. Then in 1964, Kumar Patel invented the carbon dioxide laser that was high power, widely used for cutting welding. Then various researchers developed anti-arc laser and semiconductor laser that were used in medicine, communication, and electronics. Then in 80s to 90s, various researchers built lasers, fiber lasers that came into existence that were used in eye surgery. Then ongoing it is that ultra fast laser advanced fiber optic communication. These are used in cutting edge research and applications. Now this was the history of laser. What is a laser light? It was definition I gave you about the laser light. I gave the difference between the ordinary light and laser light. Then we studied about the history of laser light. Now what are the concepts of laser light? How laser light is produced? That we'll know. For that, now we'll go to three quantum processes which are very important to know about laser. What are three quantum processes? In 1916, according to Einstein, when the radiation interacts with matter, results in the following three quantum processes: stimulated absorption, spontaneous emission, stimulated emission. These are the three quantum processes which are happened in a matter when it is radiated with energy. When energy is interacted with that matter, these three quantum processes are possible, that are spontaneous, that are absorption. First of all, absorption of light. Second is spontaneous emission, and third is stimulated emission. Emission or absorption takes place by quantum of energy called photons. And the energy of one photon is called, of quantum energy is energy of one photon is equal to h nu, where h is Planck's constant and value of h is 6.625 into 10 to the power minus 34 joule per second, frequency of radiation. Now one by one we will study these processes. What is the stimulated absorption or induced absorption? What do we understand by this process? By definition, when atom absorbs a photon, like we'll see in this diagram, you can see this, in this diagram, we can understand the process of stimulated absorption. What is absorption? Now, absorption is this: when matter consists of many atoms. Matter is made up of many atoms. In atoms there are energy levels. Let us consider two energy levels, E1 and E2. These are two energy levels of atom. Now when energy is given to that matter, or subjected to that matter by through any type of energy, like radiation. Radiations when reach to that matter, and what happens? Photons of that radiation have energies. Energy of photon is equal to h nu. By absorbing this energy, atoms from lower energy state or ground state are excited to higher energy level. This process is called absorption of radiation. This is called absorption of radiation. Like this we study radiation is an atom absorbs photon. Photon is a particle of light. Light is made up of tiny particles. Light is made up of particles which are called photons, and this photon consists of energy. And energy of photons depends on frequency of that light. Like if frequency of light is nu, then energy of photon is equal to h nu. Now condition when these atoms will get energy from that photon, when difference of that energy levels is equal to energy of photon, then that atoms get energy from photon and it jumps to higher energy state, that is excited state. Process is that photon plus electron is equal to excited electron. This process depends on the probability of absorption depends on number of electrons in ground state and photon energy density. Probability of absorption depends on these numbers. Probability depends on P12. P12 means atom going from ground state to excited level P12. It is proportional to U nu. U nu is equal to energy density of photon, means how much photons are present per unit volume, and it depends on number of electrons in ground state. Now this implies that P12 is equal to B12 U nu. Here B12 is Einstein coefficient of absorption of radiation and U nu is photon density. And that in diagram you already understand this, how energy is absorbed by the atom and it is excited to the higher energy level. This process is called absorption of photons, and this process is called absorption process, absorption of radiation. Now after absorption of radiation, we go to spontaneous emission, second process. This is second quantum process. What is spontaneous emission? Spontaneous emission also we can understand from this diagram. When atoms go to its higher energy state, excited state, like E0 is ground state and E1 is excited state. When atom is excited to higher energy level, then in excited level, atom cannot remain for longer time. That remains only for 10 raised to minus 3 seconds. Then it comes to its lower energy state, imparting the energy of H nu, which energy he gained from electron photon. That energy now it emits and we get radiation of H nu photon. Here we get radiation of H nu photon. This process is called spontaneous emission. This process is a natural process because no atom can remain in excited state for longer time. It remains for very short time, that is 10 raised to minus 3 seconds, and then it comes to its ground state. This process is called spontaneous emission of radiation. In spontaneous emission, excited electron emits photon and return to ground state naturally. Lifetime of excited state is 10 raised to minus 8 seconds. Condition is that E2 minus E1 is equal to H2. We get photon of energy H nu. Photons emitted in random direction. The rate of spontaneous emission depends on the number of electrons in the excited state. The electron changing from one state to another state occurs naturally. It depends on characteristic property of the material. The photon emission occurs naturally. It emits spontaneously. Probability of spontaneous emission of radiation is A21, where A21 is Einstein coefficient of spontaneous emission. Now next, but very important step is stimulated emission of radiation. This is very important for laser action. Like we studied the full form of laser is light emitted by stimulated emission of radiation. Now, what is this stimulated emission of? What is this stimulated emission of radiation? Stimulated emission of radiation. Now in stimulated emission, the process in which an excited electron is stimulated to emit photon. In this state also, the atom which is excited to higher energy state will come to its ground state. It will emit light, but this process is done by stimulated process. It is an induced process. What happens in this process? We can understand from this diagram. When light is excited to higher energy state, now we know that higher energy state is not a permanent state. Atom comes to its ground state. But in stimulated process, what happens? Means इसमें क्या कराया जाता है? When atom will come to its ground state, this process is done by stimulating this process, like one photon of the same energy is radiated from outside. This photon will trigger this photon atom to come to its ground state. Then these two photons will be emitted simultaneously. Now this process is done by triggering, not by spontaneous process. It is done by triggering. Outer photon is made that photon to go together. This is called stimulated process of radiation. Now we can understand by this the process in which an excited electron is stimulated to emit photon while returning to ground state is called stimulated emission. Again, the process in which an excited electron is stimulated, like a spontaneous process, atom spontaneously come to ground state. There was spontaneous emission, but in a stimulated process, the excited electron is stimulated to emit photon while returning to ground state is called stimulated emission. The stimulated occurs by applying an external energy or by inducement of photon in an excited state. The electron gets de-excited to ground state by emitting additional photon of same energy, same frequency, same phase and in same direction, which follows coherence. This phenomenon is called stimulated emission of radiation. Therefore, stimulated emission, each incident photon generates 2 new photons. This is only the method to produce coherent light which is applied in laser. This is a must reaction in laser. Probability of stimulated emission depends on photon density which we are sending from outside. P21 means atom comes from excited state to ground state. It depends on u means photon density, photons which we are sending for triggering the atom to come down. Where P12 is called the Einstein coefficient of stimulated emission of radiation and u is called photon density. So these were three quantum processes when matter was subjected to energy. Now here we studied about while studying these three quantum processes, we studied about three constants that were Einstein coefficient of absorption of radiation, Einstein coefficient of spontaneous emission of radiation and Einstein coefficient of stimulated emission of radiation. Now another question is that we derive relation between Einstein coefficient A and B. Now before doing that relation that I will teach you tomorrow, before doing that relation, because it is a very lengthy mathematical process, before studying that, we first come to know about some concepts which are very important terms we should know before we study about laser. These are population inversion, pumping, metastable state, optical resonators, laser components and laser principles. These are some important terms which we should learn before studying laser. Now what is population inversion? Population inversion is the process, like all of us we know that atoms which are in matter, in atoms there are many atomic energy levels. In that atomic levels, most of the atoms remain in ground state because that is a stable state. And for laser light to happen, we require more and more atoms in excited state, which is an inverse process. Like there are atoms in ground state, probability is there, stability is there in ground state, but we require atoms in higher energy state so that we can follow laser action. This is called population inversion. This we have to create in that device for laser action. This is called population inversion. Now population inversion is what? The number of atoms present in excited state or higher energy state is greater than the number of atoms present in ground state or lower energy state. This is called population inversion. As the name suggests, that in the inverted phenomena, in general the lower energy level is more populated, which means it has more number of atoms in lower energy level as compared to higher energy level. But by pumping we will obtain a state when the number of atoms present in the higher energy state is greater than the number of atoms in the lower energy state. We have to create the state where higher energy levels are more populated than lower energy level. That state is called population inversion. And population inversion is a key condition for the operation of all the lasers and other light amplification devices. like in diagram we can understand this is ground level and this is excited level. And in what is population, in general it happens, and N1 is very greater than N2, and in a population inversion state we make this N2 is greater than N1. This is a condition of, this is a state of population inversion which we create by imparting energy to that device. This is called population inversion. Now we will study what is pumping. There are many types of pumping, and pumping is the process in which we create population inversion. Like to achieve population inversion, we have to do the process, we have to perform the process for that device, that is called pumping. Pumping is the process of raising large number of atoms from lower energy to higher energy level is called pumping. And there are many types of pumping, like optical pumping, electrical pumping, chemical pumping, direct pumping, thermal pumping, inelastic atom-atom collision, injection current pumping. These are many types of pumping which are performed in device so that we can create population inversion. Population inversion, that is more atoms in the excited state and less atoms in the ground state. Now we will understand one by one these pumping processes. First of all, optical pumping. What is optical pumping? Optical pumping uses strong light source for excitation. As the name suggests, light is used to achieve population inversion. Solid state, there are many types of lasers also invented. In different types of laser, different type of pumping method is used. Like in solid state laser, which is a ruby laser, which will I teach you tomorrow or the day after tomorrow or during this topic. So in solid state laser, the method which is used for pumping is optical pumping. Solid state lasers use this method generally for optical pumping. Xenon flash lamps are used for pumping. Optical pumping, xenon flash lamps are used. Since these materials have very broad band absorption, a sufficient amount of energy is absorbed from the emission band of flash lamp and population inversion is achieved. Example of optically pumping lasers are UV laser, ND YAG laser. These are both solid state laser. Like laser are also three types of laser are there: solid state laser, gas laser, liquid laser. There are all types of laser. But in solid laser, we use the method of pumping we use is optical pumping. Now next is electrical pumping. What is electrical pumping? This is also a method of giving energy to the device so that population inversion is created. This is electrical pumping. Electrical pumping uses electron impact for excitation. Gas lasers use this method since gas lasers have a very narrow absorption band. Thus, here flash lamps are of no use. Electric discharge is electric current or flow of electron. Thus, electric discharge acts as a pump source. A high voltage electric discharge is passed through the laser medium of gas. After that, the high electric field speeds up the electrons to high speeds, resulting in collision with neutral atoms in the gas. Thus, electron gain energy and get excited. This is this type of pumping. Now, after this, we study chemical pumping. What is chemical pumping? Chemical pumping uses chemical reactions for excitation. Chemical reaction may also result in excitation and hence the creation of population inversion in a fused system. An atom or a molecule produced through some chemical reactions. If they remain excited at the time of production, then it is a source of pumping. For example, H2 plus F2 is equal to 2HF. In this chemical reaction, iron H2 and fluorine F2 molecules are chemically react. These molecules combine to produce hydrogen fluoride molecule in an excited state. This is also a type of pumping. Now, after chemical pumping, there is there are many pumping like direct pumping. In we use direct conversion of electrical energy into light energy. Thermal pumping. In some cases, we can achieve population inversion by heating the laser medium. Heat acts as a pump source in thermal pumping, inelastic atom-atom collision. In addition to electric discharge method, here also high voltage electric discharge acts as a pump source. However, in this method, a combination of two types of gases action are used. Injection current pumping. In case of semiconductors, injection of current through the junction also results in population inversion among the minority charge carriers. Examples of these systems are GAASN, IAM. Now, next topic, there are many, like I told you about many terms we have to know, like this. I told you before also some important terms we should know before we study about laser. I told you about population inversion. I told you about pumping. Now, what is metastable state? What are optical resolators? What are laser components? What are laser principles? All this we